Hello, I'm going to do a couple of problems here on section 2.5. Hopefully this will help you out here. This section is called non-homogeneous equations and undetermined coefficients. So if you have any difficulties with this, please feel free to get a hold of me here. I'm testing my pen. Okay, so here's our differential equation we have right here. So we're going to have the third derivative of y plus 4 times the first derivative of y. We would like that to be equal to 3x minus 1. So the first thing I want to do here is note that if we solve the homogeneous equation, y triple prime plus 4y prime equals 0, we will get the following. So here's our characteristic equation. And if we realize that it has roots r equals 0 and r is equal to plus or minus 2i, which gives us this solution right here. So this is the general solution to the homogeneous equation. So there, in your book, they talk about this rule 1, rule 2, rule 3 business. So by rule 1, meaning that we can choose our particular solution to be this. Now, if you look at that, notice that, I'm going to circle this, we would have this a2 as a constant, right? And notice that there's a constant term in this linear combination for the general solution as well. So what this means is that this particular solution will not yield a non-trivial solution. So what we need to do is to alter our particular solution that we're going to try, and we have to multiply it by some power of x so that the resulting particular solution, y sub p, that we're going to try as our trial solution, does not appear in the homogeneous equation. So what we can see here is that if we choose just to multiply by x, that will do it. And so this is what we're going to attempt to have as our particular solution. It'll be some constant a1 times 3x squared plus some constant a2 times x. So then following through, you'll see on this next line, I'm calculating actually the derivative of y sub p as I've illustrated up on this line. And then I'm going to do the following. I'm going to plug that into our differential equation, and that's what we have here, y sub p, the third derivative of it, plus 4 times the first derivative. Well, the third derivative of our particular solution is 0. So we have 0 plus 4 times y sub p, which is equal to this. So what we need to have here for our solution is that we need to have the following. We need to have 24 times a1x plus 4 times a2. We need that to be equal to the right-hand side of our differential equation. That is 3x minus 1. Okay, so that results in the fact that we need to have a1 equal to 1/8 and a2 must be equal to 1/4. So putting that all together, we arrive at a particular solution right here of y sub p is equal to 1/8 times the quantity 3x plus 2. There's a bit of algebra involved in arriving at that conclusion. Please carry that out on your own. Okay, so the next one. Let's take a look at this. Let me read the instructions here. It says for number 27, it says, okay, set up the appropriate form of a particular solution y sub p, but do not determine the values of the coefficients. Okay, so here we have it. We have this differential equation right here, which you can look at. So we're taking the fourth derivative of y, we need the second derivative of y, we need y, put some coefficients in there, and we want that to be the sine of x plus the cosine of 2x. So the first thing I want to look at is, let's take a look at the homogeneous equation and see what the solution to that is. So once again, as we've done many times in this class, we are going to find the characteristic equation, which is r to the fourth plus 5r squared plus 4. And then if you do this little substitution, s is r squared then you can realize that what we're trying to do is we're trying to factor this this particular polynomial, and that factors as ooh, son of a gun. Let me get back here. So that factors as undo that. Okay, so that factors as, son of a gun, my pen is getting out of control here, as we see here, is s plus 1 times s plus 4, resulting in, after resubstituting s equals r squared, we get r squared plus 1 times r squared plus 4 equals 0. So this gives us the general solution y sub c equals c1 times the cosine of x plus c2 times the sine of x plus c3 times 2x plus c4 times, cosine and sine of 2x. Okay, so this here is the solution to the homogeneous equation. Now notice that the right side of our differential equation is given by this f of x. Okay? So if we continuously take derivatives of that, what we see appearing are linear combinations of the cosine of x and the cosine of 2x. And this is actually an error. This right here, let me show you. Let me get rid of this. Sorry about that. That's not the cosine. By the chain rule, what I'm fixing right here, that will be the sine. When you differentiate the cosine, you get the sine, or minus the sine. And then continuing on, we would get, that's what these dots are supposed to represent. You get, for higher derivatives, you get more cosines and more sines, okay? But what you realize is that these cosines and these sines of the x, like the sine of x, cosine of 2x, sine of x, cosine of 2x, cosine of x, sine of 2x, they all are all appearing as terms in the solution of the general equation. So by our rule number 2, we have to do something. We have to multiply it by a sufficiently high power of x to give us a chance of recovering a particular solution. So what we must multiply by is just x itself, and that's what I'm illustrating here, that the trial solution or the particular solution would have this form, and that is that we multiply through by an x. Okay. Finally, in this section, I would like to do problem number 48, which is essentially the following. I'm going to solve, let me read this. I'm going to solve this equation, and for 48, we're going to be using a different technique, which at first glance looks very complicated, but it turns out it's very easy to generalize, and we'll return to this mechanism of solving differential equations in the future when we talk about systems. So this is number 48. I'll read the instructions. It says, use the method of variation of parameters to find the particular solution of the given differential equation. Okay, so to do this method, as is illustrated in the textbook, we need to first solve the homogeneous equation right here. So I'm doing that in the same way I've done it over and over and over. Find the characteristic equation, factor the characteristic equation, and luckily we are able to obtain the general solution to the homogeneous equation right here. Okay. Oh, this is a little technical. So I'm going to pick y1. If you read through this technique, we need to find two linearly independent solutions. So I'm picking y1. I'm picking, well, c1 equal to 1 and c2 equal to 2 for my example. So I'm picking y1 is e to the minus 2x, and y2 is e to the 4x. Okay. Now, for this technique, what we do is we form a system of equations. Okay. And if you're following through the text, these calculations that are done help us to arrive at the following situation. We have a solution u1 and u2, and we know that the derivative of u1 right here times our function y1, which is e to the minus 2x, plus our u2, okay, the derivative of that function times e to the 4x, we know that must be equal to 0. Now, if we differentiate our y1 and y2, we write down a second equation right here, where, as you can see, I'm taking u1 prime times the derivative of y1 plus u2 prime times the derivative of y2, and that has to be equal to our function f of x. So if we go back up here, we'll see that, in fact, there's our function f of x. So using this technique, what we will do is we'll try to solve this system of equations here. Now, what you want to notice is that, how should I say this? What you're looking at is you're looking at if you look at the system and you write it in matrix form, you would have e to the minus 2x would be the first entry in the matrix. E to the 4x would be the row 1, 2, so 1, 2 entry in the matrix. Minus 2e to the minus x would be the 2, 1 entry, and 4e to the 4x would be the 2, 2 entry. If you take the determinant of that matrix, you are looking at the Wronskian. So this is all tied in to what we had previously studied, and I recommend that you think about that. Okay, but what I'm doing next is I'm just going to simply solve this equation, this system of equations. So here we see, what I'm telling you here in this notation is that I'm going to take minus 4 times equation 1. In other words, minus 4 times row 1 plus row 2. If you do that, notice that that has the effect of killing off all of the terms involving the u2 prime. So we just simply get the equation u1 prime times a minus 6 e to the minus 2 has to be equal to this 3 e to the minus 2x. So that means that we have to have, if you solve this for the derivative, you get this equation that u1 prime has to be minus 1/2. Okay, so that means that u1, by integrating both sides with respect to x, you see that u1 has to be equal to 1/2 times x plus some constant. So what we're going to choose our u1 simply to be equal to minus 1/2 x. Okay? Now, to find u2 prime, I would take 2 times equation 1 plus equation 2. And if you look at that, that will then give us an equation that does not have a u1 prime in it. And that is, we get that 2 times, u sub 2 prime times 6e to the 4x now is equal to, has to be equal to 3 e to the minus 2x. Now if you solve that equation, you find out that u2 prime has to be equal to 1/2 e to the minus 6x. This means that by anti-differentiating both sides of this equation right here, we see that u2 is equal to minus 1/12 times e to the minus 6x. Okay, putting this all together, wait, I think I failed to tell you what the punchline is here. Okay. The punchline, and you should look in the text here, is that if you take the particular, I'll sort of write here. So the point of this calculation is that, in fact, our particular solution, okay, it will be equal to this u1, okay, times y1 plus u2 times y2. And that is what you're seeing right here. So the technique, and again, it's very nicely outlined in the text, that we've followed indicates that a particular solution of the equation will be given by the u sub 1 times the y sub 1. So here's u1 times y1 plus the u2 times y2, and this is the u2 times y2. Doing some algebra, you see that here is our particular solution. Okay, now so this technique requires that you study it, basically, but it actually works. And the thing I want you to realize is that it's successfully the successful acquisition of the solution requires us to solve a system of equations, and sort of remember that, put that in the back of your mind, because that's going to be something that we're going to encounter in the future. So I hope this helps. Please get a hold of me if this is confusing by sending me an email or giving me a call. So I will talk to you later. Thank you.